this time, we will be, and if you have height, weight, etc., can you predict the gender of the person? And maybe even smoker, smoking habit, height, weight, even blood pressure. We will use these 3-4 indicators to classify people. What is the probability that they can predict the gender of the person? And which one of these indicators actually is a better predictor of the gender? So we will look at that. Okay. So this is a pretty simple example, but it can be used in very complicated examples like predicting probability of a judgment in favor or against. Such this is the power of this model is such that it can be used to predict whether the judgment will be in favor or against. Right? Wherever dichotomous dependent variable is there, this can be used. All right. In case of a match, you want to predict who will whether a team will win or lose. You can use it. Right. So there are a number of areas where you can use. So we will be looking at how to apply, how to interpret results using a simple example that we already have. That BP example. Okay. That BP example has a few inputs on. One is on gender. Okay. We have the gender of respondents in one of the columns. That is second column. We have age. We will not use that. Then height and weight. We will be using both of them. Then smoke. We will be using this. And last one we will be using systolic or diastolic blood pressure. That is in rest condition, not with the stressor, without stressor. Okay, one of them we will use. So, or we can use both also, it will not matter. So we will use these variables as input variables and try and get the gender. That we will try and use the other variables to predict whether the gender is male or a female. Okay? Now, whenever we code the dependent variable, say we have given 0 to female and 1 to male. Now, the model will predict the probability of occurrence of the second. That means model will tell you what is the probability that the gender is male. Now, the 1 minus that would be the probability of female. So it is used to predict the second code. So for whichever outcome you want to predict, that should be coded later. Okay, so if you are coding 1, 2, that means for whichever outcome you want to predict, that should be coded as higher. That is, if you are coding 1, 2, then that should be coded as 2. Like say if you want to evaluate the probability of this judgment coming in favor, then judgment going against should be coded as 1 and judgment going in favor should be coded as 2. Because this model is set to predict the second folder that has been provided to you. That is under the research methodology folder, you have data sets. When you click on data sets, you get number of files. Out of that, bp.sat is the file that I have opened. Okay, bp.sat. We worked yesterday on this file, so you must be able to locate it. Everyone has been able to locate this file? Yes, sir. Okay, if you opened it, alright. We will be, and this analysis is under regression itself. So analyze, go to regression, binary logistic. Okay, this is called logic in short. Actually it is binary logistic. Okay, the method is binary logistic. In short, we will call it logic. Okay, click dependent variable. Now this is what we want to predict. Say we want to predict the gender of the person, subject sex. So that would become the dependent variable. And number of independent variables we will take. Say height. height, weight, smoke, and say blood pressure at rest, diastolic, systolic, दोनों और one. Okay, so we've used both. So we have used 5 independent variables: height, weight, smoke, blood pressure at rest, systolic, and diastolic. Right. So we've done that. Now 3 modules. Okay, three methods of inputting data. Input variables can be input in 3 different ways. One is using the current method that I used, enter. Okay, that means I have transferred all these either one by one or as a group and use enter as the option. Second option is that all of them I use next as the method. We call it hierarchical. Like height, I have transferred, then I use next, and then transfer weight. Okay, then I again click next and transfer smoke. Again click next and transfer say diastolic blood pressure, next, and systolic blood pressure. Right? So all have come. Right, and then I can select different things. I will not use this right now because it requires that one of the variable would be control variable. Okay, so you need to actually cancel this and restart. Okay, cancel it. We will be using the all options together. So go to regression, go to binary logistic again, gender, sex of the respondent as dependent variable, height. You can put control and select all of them together also, it will not make a difference. Smoke, diastolic and systolic. All of them can be selected together and transferred, right, without putting any next, etc. So we have done that. Okay. Look at categorical. You can transfer them to the right. Categorical variable is smoke. Whichever is a categorical variable can be transferred here. Only one was there, dependent variable. Others are all or interval scale, so we will not do that. Save probabilities. We will save membership. We will save logic. And Cook's distance is used for identifying the outliers. We need not. Okay, here we can use iteration history, case-wise listing of residuals you may not. It will unnecessarily clutter your answer. There will be the answer will become too big. So, or we can take it, we'll see first time. That's it. Okay, iteration history and case-wise listing of residuals, include constant in the model, and these two 0.05 and 0.1, and classification cutoff 0.05 and 0.2 maximum iteration. And maximum iterations it is included 20. You want, you can change it, and but 20 would be enough for this data, so I am leaving it. Alright, click on OK to find you get the results. In this, there will be 5-6 traces that would give you result, and you will interpret each one of them. The first one, if you look at total data is 181. Out of that, 179 is included for analysis. 2 we found missing data are there, they have been removed. Alright, now next the table that we need to interpret is block 0, beginning block. Now in beginning block, this output is without any of the independent variables. That means based on the ratio of the output, the dependent variable, you can identify what is the probability of a person. Like say in this data, if the ratio of male to female is 60:40, right? Now if you want to predict, the higher order was male. So if you want to predict whether a person is male, what would be the probability? 0.4, right? So that is this basic or the 0 block actually calculates that probability of the dependent variable, probability of the dependent variable coming in the order that you are trying to evaluate without putting any inputs, right? That is called 0 block. Now, under 0 block there will be 3 tables. Okay, the first one indicates the iteration history, and this coefficient should be below 0.05, then only it stops iteration. Okay, so at second iteration itself it has reached the minimum, and the -2 log likelihood value is 248.096. Please note this because we will be using it for calculating chi-square. It will be, the model calculates for you, but this will be used for calculating. This is the beginning most likelihood value, because likelihood value indicates prediction ability of the model. Okay, so 248.096 is 0. Okay, now next part is classification, 0 block only. Now this classification indicates what is the probability. That means in the sample that we have, the number of male-female respondents are equal, and that is why you find almost equal. That probability of a respondent being male is 50.8. So males might be, 1 or 2 males are more, or maybe because 2 respondents that we drop are both female, because of which this probability has come out to be 50.8. Now, from here, this model actually, whether the model is predicting correctly or if the effect of independent variables is significant or not, is calculated using 2 methods. One is chi-square, and the chi-square method is not considered very accurate in this case. The method that is considered very accurate is prediction ability. Okay, how accurately the independent variables are predicting the outcome. Okay, that is considered, and that comes from most likelihood. And in this case, the probability in this case in 0 block is 50.8 has been given. Probability of identifying a male. Now, this first block, or once you enter the independence, the improvement should be at least 25%. If it is 25% or more, then we will say that prediction is, this model is predicting it. Percentage of prediction 50.8. Okay, now it is converted into probability, and that is 50.8 squared plus 100 minus this, that is 49.2 squared. This will give you the probability. So if you square these and add together, how much it will be? Or you can convert them into fraction and square. That is better. How much is it? 0.25. And this one 0.24 something. near there. So both together will be 0.49. Now, in this case, because the probability was very close to 0.5, the percentage was very close to 50%, the probability would also come very close to that. But suppose this was 60%. So 0.6 squared plus 0.4 squared will be 0.36 plus 0.24. What's that? 0.16. 0.16, and you find it will be 0.52. Right? Whereas percentage was 60. Right? So that difference, that is why, although in our case, because the percentage is so close to 50, that this value would also come very close to 50. Alright. So, anybody is calculating this? Excel sheet to use करके calculate करिए.
Sir, 0.500128.
0.500. So 0.50, 2 decimal points. Okay? 0.50 is the probability. Now if I want to improve it by 25%, what should be the probability? 0.5 plus 25% of this. 0.5 multiplied by 0.25. That means 0.5 plus 0.125. That is 0.625 or 0.63. Correct? That means when we go to block 1, the percentage should be at least 63%. Then we will say that the model is the input variables are affecting the independent variables are affecting the dependent variable. Okay? So let us see. First, we will look at chi-square. We will find chi-square later. Okay? Chi-square block 1 के बाद आएगा, right? Now, these are the effect of individual variables on the dependent variable, but we should not actually at this moment explain them because it is zero block. That means without inputting anything. We will do it after block 1. Okay, block 1. Look at this. Now, these are the chi-square values. Okay, we need to look at for our model. That is 147.53. The chi-square value is 147.53. From where has it come? It has come from the iteration history. See, -2 likelihood after block 1 is 100.513. What was the -2 log likelihood in the zero block?
48.09.
Subtract 100.513 from there and you will get 147.583. Okay? That is the last -2 log likelihood in the zero block minus the last -2 log likelihood in the block 1. That will give you your chi-square. And it is significant at 0% level of significance, indicating that, see, now what it says is that actual probability, actual percentage and predicted percentage. If there is a significant difference, initially your assumption is or the hypothesis is that there is no difference. In the predicted probability after putting in the input variable, independent variables, and with respect to the no input or no independent variables, the difference is not significant, or the probability or percentage would remain same. Chi-square 147 significant at 0% indicates that the null hypothesis is rejected. That means our independent variables are affecting the probability significantly. That means they are altering this probability significantly, and we will see whether they are doing it. Okay. This is the chi-square on top. This table, modus everywhere, Nagel करके this is the chi-square, this is the r square, it is equivalent to r square value, but then it is not considered very accurate, so don't interpret this. Nagel करके r is not considered very accurate, so don't interpret this. Okay, now look at this. This is the percentage after the when we have entered all the independent variables. 89.9%. 89.9%. Now it should have been 62. Had it been only 25%, if change would have been 25%, it would have been 62.5 or 63% at the most. Whereas it has gone to 89.9%. So your independent variables are predicting the dependent variables significantly. Okay, they are improving the prediction percentage far more. The prediction is far more than what it would have been without the dependent variables. So therefore, they are making a lot of difference. Second is, which one is making how much of difference? Okay, what is the effect of height? What is the effect of weight? What is the effect of smoke? What is the effect of blood pressure? And so on. We will see that. Now, the prediction is given in terms of exponential way. That is, natural log to the power. Okay, natural log to the power. Exponential, these are the values, exponential b values. Okay, so if I consider this as exponential b value, first one, height, the effect is, and you know, if it is greater than 1, that means positive effect. Okay, exponential 1, if value is greater than 1, then effect is positive. And if the values are less than 1, the effect is negative. Okay, so that is first interpretation, that whatever values are greater than 1, they have positive effect on prediction. And whatever have less than 1, they have negative impact on prediction. Now let us see. First one, height, 1.563. Now look at, and the results would be different if you code them differently. Okay? It is indicating the value is 1.563. The two things can be interpreted separately. Now, Ward statistic can also be interpreted. Ward statistic values, and they are significant. Now, the Ward statistics indicates only whether the effect is significant or not. And the exponential b indicates which side is the effect. Okay, now first one, the exponential b is 1.563, that means positive effect. And how much? How much it is more than 1? 56.3%. 0.563, that means it improves the prediction by 56.3%. So the first, height is able to improve the prediction by 56.3%. Next is weight, 1.027. Again it is positive prediction. Higher the weight, higher the probability that the respondent is male. We are predicting male. Higher the taller the person, probability of a male improves by 56.3% in the first case. In the second case, 1.027. Now weight makes a difference of 2.7%. It is positive. That means higher the weight, probability of a respondent being male is more, but that difference is only 2.7%. Right? Smoke. Now if you look at, if you convert this exponential b is 0, that means no effect. Okay, it will not make any effect. 0 indicates no effect at all. Okay, if you look at 1, there also it will indicate level of significance is 1. That means the smoker or non-smoker, it doesn't affect. This data is coming from US. Okay, so it doesn't make a difference whether that means there are equal number of smokers among male and female there, and that is the reason why smoking habit does not predict whether the person respondent is a male or female. Next is systolic blood pressure. Now you find again it is significant. One statistic is significant. That means prediction is significant. Now we will have to see which side. Value is 1.112. That means positive. That means higher the systolic blood pressure, it is more likely that the person is male. Okay? 1.112, higher the blood pressure, it is more likely that the respondent is a male. And the prediction improves by 11.2%. Right? So it helps you predict. Next is diastolic blood pressure. Now it is, again the effect is significant, but the effect is opposite. And you find the value is less than 1, indicating there is a negative effect. And the effect size can be calculated by subtracting this value from 1. So 1 minus 0.884 means 0.116. That means 11.6%. That means prediction is significant, but it is more likely that if the diastolic blood pressure is high, it is more likely that the respondent is a female, and that is increased by 11.6%. And the last one, constant you should not predict. You should not interpret the constant. That's it. One more very important aspect, whether you should use these results or not, they are dependent on standard error. This standard error. And other than constant, you must check all. Right? That means if the standard error is more than 2, this data has numerical problem. If this value is more than 2, standard error value is more than 2, the problem has numerical problem. This input variables have numerical problem. And if they have numerical problems, you can't interpret the results. Now, does this have numerical problem? Does our problem have numerical problem? Yes. If you look at smoke, you find that the value is too high. Now, when does this happen? There are 3 reasons for this numerical problem to occur. And all 3 we should avoid. 1, that smoke is predicting, or smoker is predicting the dependent variable in one or the other side. That means if all the male were smokers and all the female were non-smokers, then numerical problem will occur. Because then by just looking at smoker, you are able to identify 100%. Then why do you need to do logistic regression? You don't need to. So if one of the independent variables is predicting the dependent variable completely, then you find that numerical problem would be there. 1. 2. If the independent variables have multicollinearity, high multicollinearity, then also numerical problem would be there. Okay? If the independent variables have high multicollinearity, again a numerical problem would be there. So this numerical problem, and third is that if whatever number of groups are formed on the basis of the independent predictor, if in one group the number of dependent variable respondents are 0, okay, if number of respondents are 0, then also a numerical problem would be there. Okay, so 1, if the independent variable can predict it fully. Second, if the one of the categories having 0 dependent variables, the dependent variable values. Or third, if there is multicollinearity between the independent variables, then numerical problem would be there and you cannot interpret the results of the logistic regression. What should we do? If we find that, we must remove the variable that has problem. And in our case, it is the smoke. Maybe that one category in gender, one gender was all were smokers, in the other all were non-smokers. And because of that, you find the results are like that. So what do we do next? Again carry out, analyze, regression, binary, and remove smoke. And for this, don't interpret the constant. Okay, constant need not be interpreted. So look at this. Now you find all of them are less than 2. It is supposed to be less than 2. Any standard error more than 2 indicates that it has numerical problem. Now in front of constant you find that standard error is 8.675, and I said that do not look at what is the standard error in front of constant. You should not look at that. For any other variable you find the standard errors are okay. Now if you look at, you find the probabilities have changed. Is that correct model now? And even here the prediction probability has also changed. It has become 90.6. Earlier it was 89 point something. And without putting these variables, the probability would remain same, 50.8. That means for 25% improvement, our requirement was same, 62.5%. Whereas with introduction of the induction of the input variables, it has gone up to 0.9, 0.96, 90.6%. This is far more. So that means input these variables are now predicting the dependent variable problem. Now that is logistic.
My question is that this binary logistic model is applicable to those cases where we can classify two different groups, correct?
Yes.
Now, the example which you have quoted that we have two categories of smokers, one smokers and the other non-smokers. So what?
I get to.
Now what you have said.
Dependent variable was gender, not smoker, non-smoker. Smoker was independent variable, and we found that maybe that this independent variable is predicting the dependent variable fully. That means one category, all of them might be smokers, or majority may be smokers, and the other. So one is that one category is all smokers, other non-smokers, or majority smokers and very few non-smokers. Second, maybe that one group has 0 respondents. That means in one group all smokers, in the other 0 smoker. And third, that the smoking may be all the 4, 5 independent variables may have multicollinearity. That's what I was talking. That if any one of these conditions are there, then numerical problem would be there.
Does this model apply to cases where the respondent is undecided? For example, sometimes if somebody has to choose between two alternatives, but if that person is unable to settle for an alternative.
We are not asking the person whether the person belongs to one or the other group. We are only evaluating his characteristics. We are not asking him see in our case, if we don't ask the person the gender, we ask, we take these values and we want to predict whether the person is a male or a female. Okay? We are not asking him, are you a male or a female? Right? Like in case of, say, parties that I said, whether you are going to vote for BJP or you are going to vote for any other party. You can't have like this, that are you going to vote for BJP or Congress or any third party? No. It will, the dependent variable should be dichotomous. That means one party or the others. That means are you going to vote for BJP or you are not going to vote for BJP? Because people who are going to be absent also have to be categorized under not voting for BJP. So that is how you can use it. You have to classify it into dichotomous categories and then use it. Yes, whether an organization would be financially successful, like you are starting a venture, okay, a new venture, and you have some characteristics. That means whether this person or owner has some business experience, whether he is professionally qualified, whether the person has financial background or whatever. You can have number of data that will predict whether the business venture would be a failure or it will be successful. You can apply this model. Why not? It can be done based on secondary data. That when the organization started functioning, these were the conditions, and then you can look at whether the organization failed or was successful, and you can use that to develop a model. What is the probability that these characteristics will predict whether the organization would fail or it will be successful? The banks they might not be calling it logistic regression. The banks are using all that. Yes, it can be. It can be used for that.
What is the predictive accuracy of this?
See, predictive ability of this model is 90.6.
No, I'm not asking about this case. I'm asking about the logic model. What is this?
That cannot be said because it all depends on your data. How complete your data is. See, if you want to predict, as Madam had asked, that can you use this model in finance? I said yes. Whether a business venture will fail or it will be successful. Right? You want to predict that. So how many variables, how much data you have on different variables, and whether that data is accurate. Currently, whatever organizations have failed or have been successful, if we have enough variables that predict this and data is accurate, I am sure that model can start predicting that whether the organization would fail or the organization would be successful. Alright, so this was logistic regression for us. We will move on to structural equation modeling. We had done confirmatory factor analysis yesterday. We will move on to structural equation modeling. The major difference in confirmatory factor analysis and structural equation modeling is the way you frame the model. That's it. Once you have framed the model correctly, after that the process is same. Okay? So let us do that. Okay? So how do you convert that into a structural equation model? Right? The model was already there. How do you test it using structural equation modeling? Now we had few variables, independent variables and one dependent variable. Okay? We had some factors. Each one of them had some factors. Now, what we will do is, these would convert into the manifest variables. Okay? And we will look at, and we will have, the factors would become manifest variables. Like suppose if it had 4 factors. Now, this is how the manifest variables are represented by a rectangle. So suppose if there were 3 factors for the first one, first variable was trust, second was quality, service quality, this was patient satisfaction, and this was loyalty. Now suppose patient satisfaction had 3 factors. arrays would be there with all. With them also there will be arrays. And say patient loyalty had two factors. Alright, and then you can have the relationship that we had assumed. Now, this is how the model would be prepared. That means it is second level model we call it. In SEM, you can have first level model or second level models. When you are using factors as the manifest variables, it becomes second level model. If you are using actual statements, responses to the statements as manifest variables, it is first level model. Okay? So first level or second level model you can use. Now how can you use the first level model? Could we have used first level model? In that case, our factors would become oval. Isn't it? Because they are latent variables, and latent variables would be shown by ovals. So our factors would become oval. Our statements would have rectangle. They would be represented by rectangle. Now, once our factors are oval, how would you represent the variables? Okay. Now variables can be represented by either a latent variable, that we call it, that it is also a latent variable, or we can represent it by that manifest variable that it is evaluated. Both the cases the model will not understand. Okay? In both the cases the model will not understand whether this a rectangular means a manifest variable, or that the manifest means a statement, or it is a variable which is formed on the basis of the factors. These are some of the issues that you need to keep in mind while developing a model. Suppose this was only a two variable model. Suppose it was a two variable model, service quality and loyalty. Okay, patient loyalty. And this is service quality. Alright, then service quality I could have indicated in terms of service quality 1, service quality 2, service quality 3. Now they become factors and they are affecting the dependent, and you can have the actual statements here. Suppose 4 or 5 of them were on this, 3 on this, and 2 on this. Right? And there are errors. And same way loyalty at 2. 6, 7. Loyalty is considered as 1, so 6, 7 were there on that. These are the statements, 6 or 7 statements. Those are measuring loyalty. So this is another way of putting a SEM model. So either you use this method wherein because actual data we are collecting on statements, so we can treat those statements as manifest variables. Or if we are using too many variables, then you can't have all the statements represented on a model, because then you would not be able to see anything. Okay? So therefore there it is better to convert it into second stage model. We call it second stage model. In second stage model, the sum of responses on the number of statements in a factor, okay, that would become the manifest variable. And so that means all the factors would become manifest variables, and then you can see the relationship between different variables. And variables per se are latent variables there. Okay, variables are considered there as latent variables, and the factors become manifest variables. Right? So that is how you can model and you will get the results. Now let us see one or two results. Service quality, what is it? Word file. Yeah. We have done this. Okay, first CFA for service quality. So how many variables, how many factors are there? 3 factors are there. Similarly, the factor analysis, confirmatory and exploratory factor analysis should have been done on the others. They have already been done. And if you look at a table in the Excel file, you would find I don't think it has. So we'll have to do it because it is that sheet is not there with you. So even if I use that you will not be able to see. So therefore we'll have to do it ourselves. Okay. It will take lesser time to do it than transferring from the other places. So we'll continue using that healthcare data, and we've already seen the factors on factor 1, 2, 3. Service quality we have seen. We need to look at patient loyalty. Patient loyalty, I think that was only one factor, so we will not need to do the confirmatory factor analysis. Okay, please use the patient loyalty Excel sheet, transfer it into the, for exploratory factor analysis, transfer it to SPSS. Copy patient loyalty. What we are doing right now is trying to develop the factors for carrying out structural equation modeling. Okay, since that sheet with factors is not available in this, we will carry it out again. Okay, this is the data. I will remain in data view. Go to dimension reduction factor. Transfer all the 7 to the variables window. Descriptive KMO and anti-image. Continue. Please move with me. Principal component based on eigenvalues, unrotated factor solution, equations 25, go to rotation, select Verimax, iterations 25, continue, scores you don't have to, go to options, sorted by size, suppress values and make it 0.4 at least. Click OK. And it has converged on single factor. Okay, look at the KMO values. It is 0.887, far more than 0.5. Chi-square is significant. Look at the diagonal values. All are greater than 0.5 and a single factor has emerged. Since there is a single factor, we don't need to carry out confirmatory factor analysis. You can't do confirmatory factor analysis if the variable has only one factor. So we will use this a single factor for the loyalty. Now you can close this window and use you can close the input file also and use another variable. Loyalty we have seen, and we don't need to do anything because there is a single factor. We done on quality, we will do on customer satisfaction. Yes, customer satisfaction. Okay, customer satisfaction, we take it to again SPSS. Cancel transfer. So it will give you a lot of practice on CFA. Alright, we've got the matrix. Now let us go to this factor, dimension reduction factor, transfer to the analytical window, descriptive again KMO and anti-image, extraction will remain same, nothing to change, rotation we will select variables, nothing else to change, options sorted by size and suppress values below 0.4. Click OK. Again, KMO value is 0.918, very high, and chi-square is also significant at 0. Therefore, the data is suitable for factor analysis. Look at this diagonal. You find all the values are coming greater than 0.9. All are greater than 0.9. Okay, they are all greater than 0.9 because the statements that did not have already been deleted. Okay, that it is not that every time you carry out factor analysis this will be the status. That won't be there. Now, there are three factors in this also, and we need to note down the statements from the rotated matrix. F1, 2, 4, 6, 8 and 16. Factor 2, 14 is not there. 14 is deleted because 14 has less than 0.4. So 1, 15, 9, 3 and 10. 1, 15, 9, 3 and 10. And last one, 17, 13, 5, 7, 12, 11. Okay, so these are the factors. These are the these are the statements that have converged on three factors. We will use this. We will not go for CFA on this. We will use this as if CFA has been done on this. Okay. So we go to the Excel sheet. It is already copied, and open another sheet. We copy this into that, paste, and we need to have that insert one row so that we can put that numbers. Okay, statement numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, these were the statements. Alright. Now, which statements are there in factor 1? 2, 4, 6, 8, 16. Okay. Alright. Two, 4, 6, 8, and 10, 16. This is factor 1. And we can do the sum. Next factor, 1, 3, 9, 10, 15. 1, 3, 9, 10. So 1, delete column between. So at least 1 and 3 can be there. 1, 3, 9, 10, 15. This is factor 2. Sum. And then the next factor, because 14 would be deleted. Okay, 14 is not there. Remaining all would be there. Delete. So last one is 5, 7, 11, 13, 15, 17. 11, 12, 11, 12, 13, 17. You are 11, 12, 13, 17. Correct. This is factor 3. and there should be no gap. So we will delete any column that is existing still. So there should be no gap between columns. Ensure that. So now this is saved, and we can put it as customer satisfaction factors. Rename it cust FATOR factor, right? So that later on we don't have to search for it. Customer factors, CUST FACTOR. So we got now quality. Only trust is left. If a .csv file is already existing, we can copy paste in that itself. Okay? Copy paste in that itself, and that is like say we had service quality. सर्विस क्वालिटी के फैक्टर्स कहाँ निकाले हमने? सेपरेट शीट इज देयर. कस्टमर फैक्टर तो है, ये है. This is the sheet. Okay, this was quality, service quality. All right. So we will move all of them into a single CSV file, and CSV file for trust is existing, so we will move it there. Okay. So where is that CSV file? In the same folder? Yeah, service quality CSV file is there already, and trust also CSV file is there. Okay, there are two CSV files that are already available. So what we will do is service quality CSV file we will use as the base, and we will move the other data into this only. And we will put service QUA service cost, so that we are able to understand that this is service quality data, and that is F, K and P. So F2, K2.
So we can name the factors as qual 1, 2, 3.
Yes, that would be better. SERQUA 1. Give the names as SERQUA1 so that we don't get confused. SERQUA2 and SERQUA3, and this can be deleted now. But what we need to do is we need to move these factors into one file. All these factors have to be named like that and moved to a single file. It could be that you can save these factors separately, or you make them in another Excel file. Okay? All right, we will use this copy or cut and save as. Values पे से आएगा. You need to save these factors as values so that the what we have to do is factors on all the files, Excel files, you have to club together in one Excel file. Okay? You can't use these CSV files because they have the original data. So you have to move to a common CSV file wherein only factor data will be moved, and you have to give their names so that they can be identified that the factors belong to a particular variable. Now, say you have this open a Excel file. Here itself you can open one. And we can name it SCM data. So take from first service quality. Control C, we are saving it into another Excel file. And paste special, only values. Okay, and this was service quality, SERQUA 1. Please transfer all these factors into a single Excel file. Okay? And use paste special so that the value or paste values so that the values don't change. And keep giving these factors proper names so that later on we don't forget. So service quality all have been moved. Now we will move after service quality, customer satisfaction. And customer satisfaction we should give CUST SAT 1, 2, 3.
Sir, this was
Yes?
so this was factor 3. Good.
Acha, first one was factor 3.
Yes, sir.
Okay. Then 2 and 1.
Yes, sir.
This is one, last one. Okay. So satisfaction, quality. Next was trust. And trust we already have a file, so we can take it from there. Trust. Healthcare company. Trust. new format for naming these, that is trust 1 plus 2. Instead of the original ones, use the new name for the factors because they will unnecessarily confuse otherwise later on. Trustful is a factor 1 of trust. Don't use the original names that were given. Use new names. Okay, and only loyalty was left. Loyalty का एक ही है. Since basic loyalty has single factor, you need to use statements of the loyalty. Okay? They will be treated as factors. Loyal 1, loyal 2, loyal 3, loyal 4, loyal 5, loyal 6. Alright, so this is the file ready. You can save it as other formats, CSV comma delimited, and name of the file can be SCM data healthcare. SCM data healthcare CSV. Okay. Now there are few things that are done, and basically because I wanted to keep some flexibility. Later on, if I want to change any model, that is what I have done. Loyalty data has been fed as it is because there was a single factor, and you can't use a variable with single factor. So I have used all the statements of loyalty. There is another alternative, and that is consider loyalty as the manifest variable. You don't have to consider loyalty as a latent. You can consider it as a manifest variable. That means represented with using a rectangle. So I can do both now because I have put data for both sets. Okay. So I can make those models in two different ways. That is why I have used that. So CSV file, once it is ready, we will move. Yeah, you need to close this file. As soon as it is ready, you can save it and close it. Or while closing itself, it will save. So once you make the CSV file, please close it. Alright, if you are ready, we will move on to SEM. थोड़ा हो जाए, एक दो बचे हैं तो उनका भी। 18. Alright, you would find this other model is there. You go to File and click on New. You find the screen is clean. Okay, now we will make the model, and for making the model, as I had said earlier, you can use this. Okay, and there are 4 ovals that need to be made. For each variable, 1 oval. Okay. One, 2, 3 and 4. See, the model has to be made like that. So shape वैसे ही रखना है. And if you had some problem, you can move them right now. Okay. Alright. Now you can click on this icon, and we know that first variable has 3 factors. Okay? 1, 2, 3. First variable was trust. Trust has 3 factors. Second was service quality. That also has 3 factors. Third is customer satisfaction. That also has 3 factors. 4. Customer satisfaction has 4 factors. And now this, we have an option. Instead of an oval, I can convert it into a rectangle. Okay. This can be, you can remove it. This oval can be removed, and we can convert it to a rectangle, so that your model becomes simpler.
So it was 3 only.
Huh?
Satisfaction has 3.
What was it?
Satisfaction has 3 factors.
3 ना? कोई बात नहीं, मैं delete कर देता हूँ. पूरा मॉडल टेढ़ा लगेगा लेकिन चलेगा. All right. Now I can rotate and make this model look proper. This can remain on top, or you can move it to the bottom side, and
So it can be kept in between. It can be kept in between service quality and trust.
yeah, we can do that. And we can move that. All right.
So oval move कर दीजिए.
हो गया. Okay. Now we will have to develop the relationship, and before that we need to give names. Okay, go to object properties to give name. Okay, go to the oval, click, right click, go to object properties, and you can give name. What name? What was this? Trust. First one was trust. The second was service quality. But don't leave spaces between.
So we are creating satisfaction and
No, satisfaction. In between was satisfaction. That is customer satisfaction. And this one was service quality. No spaces in between. And this can be given the name loyalty. Okay. We find that names have been given. Now we can use the single-headed arrow. Trust and loyalty, customer satisfaction and loyalty, service quality and loyalty, service quality and customer satisfaction, trust and customer satisfaction. One more was there between service quality and trust. We can leave that. Let us say this is the model. Okay. Otherwise, I will have to put service quality also. This has to be moved slightly to the right, so that space can be made. Left or right. All right. This is the model. Correct. Got the model? Arrow तो दिख रहा है ना अभी? ट्रस्ट टू लोअर. अच्छा कैसे आया ये? सिंगल हेडेड एरो को क्लिक करना है. सिंगल हेडेड एरो को सेलेक्ट करो पहले और फिर देखिए पहले ये रेड होना चाहिए तभी first this should convert into red and then when you move the other one should become red, then automatically arrow would be connected to them. So if suppose some these letters etc are coming out, then you can use, there is an option called resize observed variables. Okay. But then, right now, we are not going to use it. First, we will transfer all the names, then we will see. Go to plugins, name unobserved variables. So, all the variables that have not been given name would be given name. Okay? And now I can adjust, but then let me transfer these also, then we will adjust. Okay? And how to transfer? Go to file, open data file. Which file we need to open? SCM data healthcare. Open. खुल गया. Okay. Go to view. Variables in data set. Now. Okay. So service quality would be moved to service quality. Customer satisfaction to customer satisfaction factors. Trust to trust. And loyalty में क्या जाएगा? Last वाला total of loyalty. So this loyalty can be deleted, erased. No. Not erase. Don't use erase. Go to right click. Go to object properties. Before you transfer, you must delete this original loyalty. And now you transfer the last one, loyalty. Okay? One. See, loyalty का पहले right click, loyalty पर जाके right click करिए, go to object properties, you would find loyalty would appear. उसको delete कर दो. Okay? Because we are transferring the loyalty data directly. Okay? One, there are few problems that are still left, I have not done, and we will do that now. Wherever incoming arrows are there, that means the variable is a dependent variable. There you will have to connect one, add a unique variable. Okay, you have to connect a unique variable. Now select this. Now loyalty is a dependent variable. Select, connect one. Now customer satisfaction is a dependent variable. Select one. So two unique variables have to be added. Okay. Now I can move this slightly by using the French code so that and use touch up for correction. Alright, and you need to give them names also. So go to plugins and name and observed variables so that they are also given names as some error values. Alright, okay. Yeah, added unique variables. Now, why we have added unique variables? Would anyone tell? We talked about it in the confirmatory factor analysis. Did we?
Sometimes values when it is come.
What happens to the model? If suppose the number of data points and the number of variables that need to be evaluated. Now, if the number of variables that need to be, number of computations that are required and number of data points, they don't match. That means the number of data points are lesser than the number of variables to be evaluated. What will happen? Unidentified model हो जाएगा. Just identified, over-identified, and unidentified. These are the three states of the model. If the model is unidentified, you cannot evaluate. If the model is just identified, you still cannot evaluate because your Cmin by df will go to infinite. Your RMSE will go to 0. There will be a number of values that will become 0. So just identified is also not okay. You need to make your model over-identified. And how do we do it? Some values we will have to give. We will need to adjust values to regression value 1. Okay? If you look at all your error values, what we have done? We have fixed them to 1. Look at all your error values. Okay? We have fixed them to 1. Alright? And this unique variable is connected so that you are able to identify it as a dependent variable. Okay? So we are able to reduce the number of the calculations, a number of variables to be calculated to less than the number of data points. And if you are able to do that, it is over identified. Okay? Over identified. And that is the situation that is needed for models. And therefore, you find that every factor or every variable, wherever the manifest variables are connected, at least one manifest variable, the regression value has been fixed at 1. Look at the arrow, the first arrows, the bottom arrows. Okay, it is automatically happening, so you think that it will continue happening. No. When you delete one of these variables, you find that your model from over identified, it will become just identified and you won't get the results. Or it will become under identified and you still won't get the results. So therefore, whenever you delete the manifest variables, you need to give at least one manifest variable has to be brought to the regression value 1. Okay? So every time you make a modification to your model, you need to again ensure that one of these factor weights are regression weights for the factor are brought to 1. Okay. Now once this is ready, now we are ready for calculations. And before calculations, you need to analysis properties have to be set. Generalize maximum likelihood we will select and fit the saturated and independent models. Go to output. Standardized estimates we want. Squared multiple correlations also we want. We want modification indices, factor score weights, direct indirect effects. We don't want covariance correlation right now. Test of normality and outliers also is not rated right now because we've already done during your transparent factor analysis. Should have done. Okay. Now the selections have been made. Click on. Now it is asking for proceed with the analysis. He is saying that there are 3 factors. Do you want to add covariances between them? Now, since we know that these are not 3 factors, we don't need to add covariance. It is asking for the top and bottom, thrust and surface quality. In fact, originally in the original model we had said that surface quality affects your thrust also. But we have removed that, but then it is okay. We will not can proceed with the analysis. Now it is asking where to save results and in which file. So SCM results. The file will be SCM results. And which SCM? Dependent variable is patient loyalty. Patient loyalty SCM results. So that you are able to identify correctly what is this, what are these results or where are these results. Okay, calculations are done. Chi-square value is very high, 626. We need to make a lot of changes. Go to standardized values. Look at the factor weights. First thing that you need to do. Look at the factor weights. This factor has got lower weight 0.45. Lower than 0.5 we need to be careful that if there are, we can delete, but shouldn't delete without looking at what that factor is. Okay? So we will see later on whether we need to delete. Alright. Now we go to results. Text results. Chi-square. MIs. These are the modification indices. Look at high values. Service quality 2 and trust 1. Okay. Then service quality 3 and trust 3. Service quality trust 1 and service quality. That means we've collected. We've not connected that. Service quality is here. Okay. Let us make one change before we go for further analysis, and that is connecting service quality with trust and making trust as a dependent variable and going to plugins and give names to unobserved variables. Okay, make that change because we are seeing that service quality and trust are having lot of common problems. Calculate estimates now. See, it has come down straight away quite a bit. Alright. Now we can check. Okay, we can check the modification fit. The Siemens has come down from 20 to 7 and these have also improved. Okay, these have also improved. So you find with one arrow we will be able to make lot of improvement. And how did we identify that arrow is needed? We checked that lot of all the factors of trust and this service quality were shown as interrelated. So then it was better that we give a relationship to them. Okay, next is modification indices. Again we will go, and now you see you need to see only this. Okay. Where is the highest? 19 E1 to E8. You know, E1 to E4, 35. Now, what is E1 and what is E4? E1 is for trust and E4 for service quality. That these two are related. 0.7, 0.4. So you need to, now we will need to look at whether some variables need to be deleted. Okay? And to do that, you need to look at modification indices and which variable, deletion of which variable would improve your results maximum. So if you look at one has 19, 23, 27 and 35, 62. If you delete one, you find your chi-square value would reduce by 62. Look at another. 2, it will reduce by 12. 3, 1, 2, 3, it will reduce by 21, 26. 4, only 11. 5. 5 is 7, 5, 12, 14, 26 and 8, 34. 6, 7, 13, 17. So, you need to remove 1. Now, where is 1? Here. Trust 3. Trust 3. Now, these major problems are because we did not carry out CFA. See, major problems are coming because we did not carry out CFA on all the variables before going in for SEM. But fine, we will be learning number of things. Okay. Now, once we have removed trust 3, we need to give 1 to this plus 2. Go to parameter and put 1 there. Okay, double click the arrow. Double click the arrow, you will find that as soon as you double click, you will find this. And under regression way, put 1. Okay, so you have got 1 here. Unless you get that, you will not be able to proceed. Next, calculate again. Yes. Actually, generally, this would ask for more than 2. We will see. It is not highlighting your this transfer. We will see why not. You can go to the model fit and check. Come down slightly. This is going slightly better. So you can't remove 1. Trust का आपको दूसरा को remove करना पड़ेगा. Look at the model fit. We have seen that some improvement is there. Go to modification indices. Check what else need to be changed. Now you find that E5 has become very the one that is contributing to maximum error. Okay, so E5 can be removed. Where is E5? E5 is here. All right. Continue check of normal. That is also important criteria. skewness is within limit. Kurtosis is the problem. You find kurtosis, none of the kurtosis is okay. Yeah. You will find that this matrix is indicating outliers. Okay? If you find any value greater than 4, you find that's an outlier. Okay? Greater than 4. You find number of values are there, somewhere 8, 9, and so on. So greater than 4 are indicating outliers. So there are significant outliers. Number of significant outliers, you need to remove them before you can go ahead. Alright, so that's it for the